Hey guys, Mr. Midas is here again with you, and I'm going to be talking about derivatives of inverse trig functions, all right? So in my previous video, I did just some review of inverse trig functions. Now we're actually getting to the calculus, and we're looking at their derivatives. So what I'd like to do is show you a problem how we get a derivative and why the inverse trig function derivatives look the way they do. So I'm going to go and find the tangent x using a right triangle. All right, let's see here. So I'm going to draw this right triangle. This is my x. Arc cosine means that my adjacent over hypotenuse is going to look like that. And then if I use Pythagorean theorem, I'm going to end up with 1 as my opposite. So my tangent x is going to be the opposite, opposite over adjacent, which is 1/2. All right, pretty much it. Okay, again, I need to use Pythagorean theorem to find that other side. Okay, so now I'm going to do that with just a general. Find cosine of y if y equals arc sine x. So I'm going to go ahead and draw my right triangle here. And you know what I'm going to do? I'm going to zoom in so you can see this better. So I'm going to draw a right triangle. My angle here is y. So since this is arc sine, that means my opposite over hypotenuse. So I'm just using a unit circle basically. Y equals arc sine x. All right. And some of you might be asking, where did I get the x from? Well, that's the inside. This is x over 1, right? So that tells me that the sine is the opposite, which is x. So opposite over hypotenuse, which is 1. And then I'm going to do the Pythagorean theorem to find the adjacent side. And if I do the Pythagorean theorem, I'm going to get 1 minus x squared. So what's the cosine of y? The cosine of y is the adjacent over the hypotenuse is over 1. So this is the cosine of y. So now let's take that into a problem like this where we have using what I just got, let's find the derivative of the derivative of arc sine. So y prime of arc sine of x. That's what we're looking for. Okay, so we're looking for y prime of that. So let's go ahead and say y equals arc sine of x. And I'm going to say that that's sine of y equals x, right, by using an inverse property. And then I'm going to use implicit differentiation. So that's going to give me the derivative of sine is cosine times y prime equals the derivative of x is 1. All right, so that's going to give me y prime equals 1 over cosine y. That gives me y prime equals 1 over, then I'm going to go and put this in here, square root of 1 minus x squared. Okay, so notice here that our answer for a derivative of a trig function actually has a square root and a 1 minus x squared. And we get that from the Pythagorean theorem, okay? So you're going to notice here in the formulas for the derivative of inverse trig functions that they all end up with 1 minus x squared in the denominator with the square root. Unless it's a tangent, then it's 1 plus x squared. So I encourage you, you're going to need to memorize these. This right here, these are the chain rule ones. So this is if you have the chain rule, you're going to take the derivative of whatever's inside and put it on top. Okay, so let's go and take a look at some examples. Let's go ahead and differentiate arctan of 2y minus 1. So g prime of y is, notice we have something inside that we have to take the derivative of, so we're going to use the chain rule version. So the derivative of 2y minus 1 is 2 over 1 plus, now x squared is in this case all of whatever's inside. And we get that from this right here. See, it's all of whatever's inside in u right there. Okay, so in this case, u is 2y minus 1. Well, you're not 2y minus, but you know what I mean. That's the Worst dad joke ever, right? Okay. All right, let's do this one here. Now, for this one, I'm going to change this to f of x equals arc sine of x to the 1/2. Okay, so we're going to have f prime of x. This is a chain rule one again, so we're going to have to do the derivative of x to the 1/2, which is 1/2 x to the negative 1/2, all over. Now this is arc sine, so it's square root of 1 minus the inside squared, x to the 1/2 squared. All right, now you can leave your answer like this, or if you want to simplify it, it's going to be simplified into 1 over 2 root x times the square root of 1 minus x. All right, next one here, number 9. Again, we've got something inside that we have to take the derivative of, right? So we're using a chain rule. So h prime of t is the derivative of the inside, which is 1 over t, divided by square root of 1 minus, oh, wait a minute, this is arc cosine. Arc cosine, the only thing different from arc cosine and arc sine is that there's a negative. 1 minus ln of t squared. That's it. Okay, so it's really going to be important that you memorize these because really they're not that hard as long as you can memorize them, all right? So arc sine of x over 2. Y prime, x over 2, the derivative of that is 1/2 over the square root of 1 minus x over 2 squared. Let's simplify this a little bit. 1 over 2 root 1 minus x squared over 4. All right, 2, this is kind of a tricky little algebra here, but 2 is the same thing as root 4, and since now I have the square roots, I'm going to go ahead and multiply 4 inside. I'm going to have 4 minus x squared. All right, and that would be your simplified answer. All right, so derivatives of inverse trig functions. It's going to be really important that you memorize these rules here. Okay, memorize sine. All you got to know is cosine is -1 on top, and memorize tangent, and you got it. Okay, and then you just put the derivative on top. All right, there you go, guys. Derivative of inverse trig functions. Catch you later. Oops, what did I just do?